Hello, this is AMA1501 Group presentation, and this is Group E. Here is our team members, and here are some free riders. And my name is Soyeon No, and here is my student ID, and I'm responsible for question 5.1. It says the claim that 42% of those persons who retired before the age of 69 would return to work if a suitable job was available. It is to be investigated at the 0.05 level of significance. If 76 out of 200 workers sampled said they returned to work, what is our decision? We are using the one sample proportion z-test. As we are using the one sample proportion z-test, here is my formula used. And as the claim says 42% of people would return, our null hypothesis, which is H0, is P equals 0.42. And H1 is P is not equal to 0.42. And also as we are sampling 76 out of 200 workers, we can use 0.38 as our this kind of P. And if we put all the figures into the formula, we can come up with the Z value, which is minus 1.1461. And we are using the 0.05 level of significance, so our critical region can be 1.96, as minus 1.1461 is between plus and minus 1.96. We can conclude that we can accept null hypothesis, in other words, do not reject, because as the test statistics have a value in the critical region, there is a sufficient evidence to conclude that people retired before 65 return to work if job is available. Thank you.
My name is Yana Lam, and I'm responsible for the question 5.2. The question is about the quality manager would like to test the so per bottle differs from the labeled amount of 200 ml, and they sample 14 bottles, and measure of the sample mean is 198 ml, and assume that follow the normal distribution for the standard deviation of 15 ml at the level of 0.01 level of significance. And I would like to prove and there evidence that the average soil per bottle is less than 200 ml to test at the 0.101 level of significance, whether there is evidence that the average amount of soil per bottle is less than 200 ml. The following hypothesis was employed. H0 equal to mu equal to 200 ml, and H1 mu less than 200 ml is the alternative hypothesis, where mu represent the population mean and HO represent the new hypothesis. HA represent the alternative hypothesis. Furthermore, it was important to have the test statistic evaluate as follow. This is a value test, and where Z is a test statistics, and X is the simple mean, and mu is the population mean, and the standard deviation, and N is the simple mean. So Z equal to 198 minus 200 over 13 over 40, and it is equal to 0.142, and this means that the exact score is 0.421637 standard deviation below the mean, and the table value, also known as p-value for Z less than and equal 0.42, donate as p Z value less than and equal to 0.42 is given as 0.3372. The table value is therefore 0.334672 or 13.72%. And in conclusion, this is exit the 0.101 significant level. Hence, we fail to reject the null hypothesis, and this means there is no enough evidence to support the claim that the average amount of social per bottle is less than 200 ml. Thank you.
Hi, my name is Wu K. Jenny, and I'm going to present the question 5.3. So, we can see I have set the hypothesis 0 to be equal to 8,500, and the hypothesis 1 is set larger than the 8,500. Because it's referred to the question, we need to find that is it there the evidence that to show it is more than $8,500. To calculate it, we find that the t value is equal to 2.5958. At 5% level of significance, the critical region is t larger than t 0.05, which refer to the t-scale table, 1.681 with the degree of freedom equal to 45 minus 1 equal to 44. So the t-value is larger than the t-value at the 5% level of significance, which is 2.5958 larger than 1.681. So we get the conclusion that we should reject the hypothesis 0, and the FH cost of tuition is more than 8,500. Thank you.
Hello everyone, I'm Kubi, and I'm handling for question 5.5. This is talking about a financial planner wants to compare the yield of income fund and growth mutual fund. $50,000 is invested in each of a sample of 35 income funds and 40 growth funds. The mean increase for a 2-year period for the income funds is 900. For the growth fund, the mean increase is 57875. Income funds have a population standard deviation of $30. Growth funds have a population standard deviation of $45. At the 0.04 significance level, is there a difference in the mean yield of the two funds? And this is the solution. We can see that the critical value of the set is positive negative 2.05. Since we have the equation, we can sub the data into the equation respectively. Then at last, we will get set equal to 2.86, which is larger than 2.05. So there is enough evidence to prove that the mean is different, and there is difference in the mean between the two funds. Thank you.
Hello, my name is Ma Suizhi. I will introduce question 5.7. This is a manufacturer of ball bearings. They are doing experiments with two different processes to test the precision of diameters according to their standards. The errors from the standard is sampled from two processes. Here are some sample statistics in the table. Assume that the population standard deviations are equal at 5% level of significance. Do these two processes yield different average errors? Here we are given statistics of two samples from two processes respectively. For process A, the sample mean is 0.2, the standard deviation is 0.1, and the sample size is 15. For process 2, the sample mean is 0.3, the standard deviation is 0.12, and the sample size is 18. According to the question, The null hypothesis here is the difference of two population means is equal to 0, and the alternative hypothesis is it is not 0. Here, we need to use two-sample t-test with equal variance at 5% significance level. According to the formula, we can calculate the degree of freedom and the test statistic, where t is approximately equal to minus 2.5674. And we can also obtain the two-tailed critical region. From the table, we can find that t with alpha equal to 0.025, degree of freedom equal to 31 is approximately 2.04. Here, we find that the test statistic belongs to the critical region. Hence, we reject the null hypothesis at 5% significance level. That's all. Thanks.
Hi, I am Gao Zilin. Now I'll introduce question 5.9. Recently, students in a public administration class were interested in the driving behavior of students. Specifically, the students were interested if exceeding the speed limit was related to gender. They collected the following responses from 100 randomly selected citizens. And what is your decision at the 1% level of significance? So this question is asking whether there are relations between two variables. So we use a chi-square test. So to do this test, we first need to know the expected value. So we first calculate the total of the actual value, and then the expected value is calculated by the column total times the row total divided by the whole total. So we get 33, 27, 22, and 18 for the expected value. Now we set a null hypothesis. Exceeding the speed limit is related to gender. And then the alternative hypothesis is exceeding the speed limit is not related to gender. Then we use the chi-square test formula, which is actual minus expected squared divided by expected, and we sum them together. And we get this chi-square statistics is 8.2492. We compare it with the chi-square at 0.01 significance level, and this is 6.635 with degree of freedom b equals to 1, and the degree of freedom is rho minus 1 times column minus 1. So our conclusion is do not reject H0, which means exceeding the speed limit is related to gender.